Good day, students. Continue our video lesson, practical lesson. Last time we solved the limit, calculated the limit by method of fraction simplification. Now solve this example, the given example, by other methods. Continue. Right. We had the example number 323. Find limit. Limit when x tends to 3 of square root of x plus 1 minus 2 over x minus 3. Solution. Now consider second method named simplification of fraction. Simplification of fraction. The first method was the method of conjugation. Solution. Transform the denominator in the following form. Limit when x tends to 3 square root of x plus 1 minus 2 over x plus 1 minus 4. Plus 1 minus 4 is equal to minus 3. Then rewrite limit when x tends to 3. Please go to the next row. Limit when x tends to 3 square root of x plus 1 minus 2 over square root of x plus 1 squared. Because you know that the square of square root is the expression under root. So under root is x plus 1 and minus 2 squared. 4 is 2 squared. Then it is the square difference, and we can separate. We can factorize this expression, this denominator. Square root of x plus 1 minus 2 over square root of x plus 1 plus 1 minus 2 multiplied by square root of x plus 1 plus 2 equals. Then simplify square root of x plus 1 minus 2 in numerator and denominator equals limit when x tends to 3 1 over square root of x plus 1 plus 2, then substitute 3 instead of x. 1 over square root of 3 plus 1 plus 2 equals 1 over, it is 2 plus 2 is, and already we obtain the same answer, 1/4. Then consider next method named the variable of change. I'm sorry, change of variable. 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 Here we can change x plus 1, the expression under root, by new variable t. For example, by t. Let x plus 1 is t. Then x is t minus 1. T minus 1. And here we must also change the tangential. Change the tangential and write tangential for the new variable t. X, if x tends to 3, then t tends. If x tends to 3, we must substitute 3 instead of x. 3 plus 1 is 4, and it means that t tends to 4. Tends to 4. Tends to 4. Then substitute. Then change the variable limit when t tends to 4. Square root of t minus 2 divided by x is t minus 1, t minus 1 minus 3. Then the limit when t tends to 4, square root of t minus 2 divided by t minus 4. Minus 4. Then we can factorize the denominator. Limit when t tends to 4, square root of t minus 2. Here it is square root of t squared minus 2 squared. Then it is limit when t tends to 4, square root of t minus 2 over square root of t minus 2 multiplied by square root of t plus 2. Then we can simplify numerator and denominator by square root of t minus 2. Then we have limit when t tends to 4, 1 over square root of t plus 2. Then substitute 4 instead of t. 1 over square root of 4 plus 2 equals 1. It is 2. 2 plus 2 is 4. 1/4. We obtain the same number. Finally, consider another method of variable change. Another change of variable. Now whole square root changed by new variable. Let square root of x plus 1 is t. Then x plus 1 is t squared. X plus 1 is t squared. And x is t squared minus 1. Minus 1. Then if x tends to 3, then substitute 3 instead of x under root. 3 plus 1 is 4, square root of 4 is 2, which means t tends to 2. And rewrite the given limit for the new variable t. Limit when t tends to 2, t minus 2, x is t squared minus 1 minus 3. Then limit when t tends to 2, t minus 2, t squared minus 4. Then we can factorize the denominator. Limit when t tends to 2, t minus 2 divided by t minus 2 multiplied by t plus 2. I'm sorry, t plus 2. T plus 2. T plus 2. Here, numerator and denominator is simplified by t minus 2. Then we have limit when t tends to 2 of 1 over t plus 2, and substitute 2 instead of t, and then we will obtain 1/4. Thus, we considered 4 methods for the calculation of the given limit. Continue. Then consider next example. 365. Find limit. Limit when x tends to minus 8 of 2 plus cube root of x over square root of 1 minus x minus 3. Solution. First, substitute minus 8 instead of x in the given expression. 2 plus cube root of minus 8 over square root of 1 minus 8 minus 3. Then it is minus 2 plus minus 2. Here 1 minus 8 is 1 plus 8. It is 9. Square root of 9 is 3. 3 minus 3, and it is 0 over 0. We obtained the indeterminate form of type 0 over 0. Therefore, we must evaluate the obtained indeterminate form. Here we can use only one method, conjugation method. For this, multiply numerator and denominator by the cubic conjugation of numerator and quadratic conjugation of denominator. Right, please. Multiply the numerator is suret in Azeri suret, in Russian числитель, and the denominator in Azeri it is مخرج, in Russian знаменатель. Denominator by the cubic conjugation of the numerator and the quadratic conjugation and the by the quadratic conjugation of the denominator at the same time. limit, right limit, when x tends to minus 8, draws a long fractional line, 2 plus cube root of x multiplied by its cubic conjugation. 4 minus 2 cube root of x plus cube root of x squared. Squared and also multiply by quadratic conjugation of the denominator. It is square root of 1 minus x plus 3. Also multiply the denominator by these expressions. Square root of 1 minus x minus 3 multiplied by the cubic conjugation of the numerator, 4 minus 2 cube root of x plus cube root of x squared, and multiplied by quadratic conjugation of the denominator. Then change the places of these factors, and then continue. Then continue. Rewrite the lower expression equals limit when x tends to minus 8, two plus cube root of x multiplied by 4 minus 2 cube root of x plus cube root of x squared. And multiplied by square root of 1 minus x plus 3. And square root of 1 minus x minus 3 multiplied by square root of 1 minus x plus 3. And finally, multiplied by 4 minus 2 twice cube root of x and plus cube root of x squared equals. Then look at the denominator. It is square difference. That is square root of 1 minus x squared minus 3 squared. But look at this product in the numerator. It is sum of cube sum. It is 2 cubed plus cube root of x cubed. Continue. Limit when x tends to minus 8, it is 8 plus x multiplied by square root of 1 minus x plus 3. Here we have 1 minus x minus 9 multiplied by multiplied by 4 minus 2 cube root of x plus cube root of x squared. Equals. Then limit when x tends to minus 8. Here rewrite in the following form. X plus 8 multiplied by square root of 1 minus x plus 3 over minus x minus 9 multiplied by 4 minus 2 cube root of x plus cube root of x squared. Continue. Here we can take negative sign out of the brackets, and then we can simplify numerator and denominator by x plus 8. X plus 8 here. Here we have only negative sign. And finally we have limit when x tends to minus 8 of square root of 1 minus x plus 3 divided by minus of 4 minus 2 cube root of x plus cube root of x squared equals. Then substitute minus 8 instead of x in this expression. 1 square root of 1 plus 8 plus 3 over minus 4 minus 2 multiplied by cube root of minus 8 is minus 2 and plus minus 2 squared is 4. Continue. It is 9, square root of 9 is 3 plus 3 is 6, minus, it is 4 plus 4 plus 4 is 12, and we will obtain minus 1 second. Our answer is minus 1 second. Now please rewrite your assignment number 232. Find the limit by method of the fraction simplification and of the variable change. That is, calculate this limit by two methods. Then here we have I give you two examples, 322 and 363. Two limits which must be solved by fourth method. First method, conjugation method. Second method, fraction simplification method. And third and fourth method, the both variable changed. In the third method, you must change only the expressions under roots by new variable, and in the fourth method you must change whole roots by the new variable. Please rewrite. Also add two limits to your assignment. Find limits. Limit of when x tends to minus 1, square root of 2x plus 3 minus 1 divided by square root of 5 plus x minus 2. And the number 367, limit when x tends to 64 of square root of x minus 8 divided by cube root of x minus 4. You can calculate these limits only by conjugation method. Then go to the new topic named the first remarkable limit. The first remarkable limit. The first remarkable limit. First remarkable limit. Remarkable limit. First remarkable limit. In Russian it is первый замечательный предел. In Azeri, this term has six translations. Birinci görkemli limit, birinci mühim limit, birinci maraqlı limit, birinci məşhur limit, birinci qəribə limit, birinci əntiqə limit. It has following form. Limit when x tends to 0 of sine x over x is unit, and it is indeterminate form of type 0 over 0, because if substitute 0 instead of x, we will obtain 0 over 0. Sine of 0 is 0. It is the first remarkable limit. This remarkable limit has several results, and then show these results. Now consider the results of the first remarkable limit. Second formula, the cosine result, cosine result, limit when x tends to 0 of 1 minus cosine x over x squared is 1 second. It is indeterminate form of type 0 over 0. Why? Because if substitute 0 instead of x, we will obtain cosine of 0 is 1, 1 minus 1 is 0, divided by 0. Then the tangent result, limit when x tends to 0, tangent x over x is unit. Fourth result, the arcsine result. Limit when x tends to 0, arcsine x over x is unit. also the indeterminate form of 0 over 0. And finally write the arctangent result. The arctangent result. Arctangent result. Limit when x tends to 0, arctangent x over x is the unit. It is indeterminate form of type 0 over 0. Thus we have the first remarkable limit itself and its four results. Please write. Then consider of equivalent forms of the trigonometric function near 0. That is when x tends to 0. And consider the behavior of the trigonometric functions. Right? The equivalent forms of the main trigonometric functions, trigonometric functions near the 0 point. These equivalent forms we can apply in the calculations of limits. First equivalent form of sine x is equivalent to x near 0 when x tends to 0. Here, for example, sine 5x is equivalent to 5x, etc. It is the equivalence symbol. Equivalence symbol. In Azeri ekvivalentlik işaresi, in Russian znak ekvivalentnosti. And second equivalent form, cosine x is equivalent to the cosine x to 1 minus cosine x squared, 1 minus x squared in half, when x tends to 0. In the calculation of limits, we can change cosine x by 1 minus x squared in half, if x tends to 0. Then tangent x is equivalent to x when x tends to 0. Then fourth equivalent form, arcsine x is equivalent to x when x tends to 0. And fifth equivalent form, arctangent x is equivalent to x when x tends to 0. Here you must remember that in the calculation of limits for only for first, third, fourth and fifth formulas, if argument tends to 0, then we can delete the symbol of function. For example, if x tends to 0, we delete the symbol of function, and then we will have only x. Here, if x tends to 0, we can delete the symbol of tangent function, and we have only x. Then also for arcsine x and arctangent x. If x tends to 0, then we can delete the symbol of function, and we will have x. And finally, if here x tends to 0, then we can remove the arctangent symbol, and then we will have only x. This rule is applied only to the first, third, fourth and fifth formulas. Then continue. Consider the following example, number 439. Find the limit by the method of the remarkable limits and of the equivalent forms. First method. Remarkable limits. This first method. First, divide numerator and denominator by x. Limit when x tends to 0, sine of 4x over x divided by tangent 5x over x. You know that the limit of ratio is the ratio of limits, and therefore we can separate limit symbols. Limit when x tends to 0, sine of 4x over x divided by limit of when x tends to 0 of tangent 5x over x equals. Then change variables. In the denominator, change 4x by new variable, for example t, and in denominator change 5x by new variable z, for example z. And please consider these changes. First change. For x is t, then x is 1/4 t, 1/4 t. And if x tends to 0, then t also tends to 0, because if substitute 0 instead of x, we will obtain that t also tends to 0. Because here we must change also the limit tension. Then consider second change. Second change. 5x is z. 5x equals z. Then x is 1/5 z. If x tends to 0, here x tends to 0, then z also tends to 0 because if substitute 0 instead of x, we will have that z will be will tend also will tend to 0. They continue. Equals a limit when t tends to 0, sine t over here x is 1/4 t. 1/4 t in the denominator limit, divide by limit when z tends to 0, of tangent z over 1/5 z. 1/5 z equals. Here 4 and 5 will transfer to the numerators. Limit when t tends to 0 of 4 multiplied by sine t over t divided by limit when z tends to 0 of 5 multiplied by tangent z over z equals. Then we can take 4 and 5 out the limit symbols equals 4/5 multiplied by limit when t tends to 0 of sine t over t divided by limit when z tends to 0 of tangent z divided by z. The expression in the numerator is the first remarkable limit itself, and its result is unit. In the denominator we have the tangent result or the first remarkable limit, and its result is also unit. Then we have 4/5 multiplied by 1 over 1. Finally we have 4/5. 4/5 it is our answer. Then continue calculate this limit by the method of equivalent forms. Second method. Equivalent forms. Return to the condition limit when x tends to 0, sine of 4x divided by tangent of 5x. If x tends to 0 according to condition, then 4x is also tends to 0. and 5x is also tends to 0. And according to the known rule, if the argument of sign tends to 0, then we can delete the sign symbol. Also, if according to the known rule, if the argument of tangent tends to 0, then we can remove also the symbol of tangent. Then we will have limit when x tends to 0 for x over 5x. Then numerator and denominator is simplified by x. Then we have limit of 4/5 when x tends to 0, and you know that the limit of a constant value is the constant value itself. Therefore, we will have 4/5. Then we have the same answer. Thank you for your attention. Good luck. Goodbye, students.